So let's take a look and see how this plays out. So I have a triangle that I want to give you a heads up will only have one solution. But I want you to see how it could potentially have two solutions. So let's solve some of what we know. What we know is we have an angle, a side, and a side. It's an ambiguous triangle that we have right here. So let's go ahead and take one of our relationships we have. So let's look at A over the sine of A equals B over the sine of the angle B. A is 81. We do know that. 81 sine of 43 equals 62 all over the sine of B. So I'm shooting for that angle right now. Let's manipulate that around and solve for sine of B. So sine of B equals 62 times the sine of 43 all over 81. Then use my little black box to figure out what that is. So sine of B equals 62 times sine 43 divided by 81. And I get sine of B equals roughly 0.5220. Yeah, roughly 5.220. Well, that doesn't give me the angle. To find the angle that I need to do is I need to take the inverse sine of B of that, or the inverse sine of what we came up with, 0.5220 roughly. And that pops out 31 degrees. And actually, I probably should save that for a second. I skipped a little bit of a step I wanted to kind of bring to your attention. Okay, given this point right here, I know that there's two angles, or there's two potential sine angle, or two potential angles that have a sine of 0.5220. And so I need to look at both those potentials. One we discovered is that it's at 31.4 degrees. But I also know that if I took 180 minus 31.4, which equals what? 149.6 degrees, I also know that that's the sine of B would equal 0.5220. So which two angles is it? Is it both? Which one? Well, I can rule this one out automatically because if I included this one within this angle right there, I would have three angles that add up more than 180 degrees. So even though this does produce a sine that I got, I have to rule that one out. That one will not work. So I know that my angle, or my sine of B, the angle has to be 31.4. It has 31.4 degrees. So I know that one has to be the case. And then from there, it's a matter of solving, because now I have two angles and a side. And solving any triangle, two angles and a side, I can do. I can find this other side of C by taking all the angles, 180 minus 43 minus 31.4. And that equals 74.4, 105.6. Did I do my math right? 43 and 31 is 74.4. Subtract that from 180, gives me 105.6. So I found that remaining side, and then from there to find C, I can look at a couple of ratios. So let's look at C over the sine of C, and something I already know, B over the sine of B. So C over the sine of C is 105. Sine of 105.6 equals B, 62. All over the sine of B 31.4. Solve that for C. C equals 62 times the sine of 105.6 all over the sine of 31.4. And gives me a length of 114.6 units. So there you have it. I was able to find all three sides when I have a triangle that I'm not sure which type of a triangle it is, but going through the work I was able to rule out one possibility and realize which triangle it had to become.